welcome. It's a pleasure to present this fairly new project that we've built, and we start in 2018. We, as a company, well, deal with a lot of different publishers, and which I propose is what are the challenges and goals today into production of EPUB-free and other digital resources, and why we choose the artificial intelligence to improve our production processes. And we'll try to show you some outcomes that we achieved to manage now. And here we go. And our platform, EasyCrunch, is a platform which is in production since 2013 for the scholar books. So we're mainly involved into education books. Your education is very complex design. So we've chosen the fixed layout EPUB-free since the beginning. And the interesting feature is because it's dedicated for a very complex layout. It's often shows in spread view, which means 2 pages side to side. It's beautifully designed, and it's really quite easy to automate this kind of production. And because we deal with e-textbook or scholarly books, there's a lot of interactivity in there, so a lot of audio, videos, and many other exercises and quizzes and so on. So this is why we choose this kind of technology. But unfortunately, because it's display-oriented, it's not very mobile, as we just understood this market today. And of course, it's not very easy for the to include accessibility into this kind of materials. And because it's display-oriented, again, it's not content-aware. So what we do now is we do hybrid EPUB, so which means we have a fairly straightforward production of EPUB-free fixed layout, and we create some widgets on top of that, and the widgets are made in reflowable content, and those reflowable content are easy to make them accessible. But we'll see the smartphone market usage is exponential, so we need to be more mobile, not to say mobile at all. And we have a high demand, specifically in education. There's a high demand for individual resources. Teachers, learners, and even students, they like to pick things everywhere, and they like to build their own resources. So what we need is we need to be able to create new resources on top of every scholar books. And to build these new resources, we have to build a resources database if you want to use it. This is what we call the modularity, so pick up what you want. And if we want to extend the usage for a disabled audience, we need to be accessible. So we need to find a way of dealing with both fixed layout EPUB and reflowable EPUB at the same time. Why do we choose the artificial intelligence, and why do we invest into artificial intelligence to help us produce such kind of materials? And the goals for tomorrow, as we said, is we had already a fixed layout production plan, but we want to have a reflow production plan, which means that we want to be able to deliver to publishers a reflow system that will be costly effective for them. Of course, it should be accessible already, and it should be easier if we are reflowable. And we need to add some semantics on that, so that means it's not display-only oriented, but we need to include some semantics on all resources that we create, as we said, for accessibility, of course, but also for the modularity in the resource database that we've seen previously. And of course, for the publisher, we should be cost effective because everybody should do that, and they may do that by hand. But the problem is to have a robust technology to produce reflowable content at an effective cost. So the problem is that the layout of such books are quite complex. And the first thing that we need to understand is how we define boxes. What mean boxes is how to differentiate, for example, images and text. This very first layer and very first differentiation. Then we have to define boxes inside boxes. So as if you look into those kind of pages, you see there's many different ways of understanding what was written into those pages, and we have to be able to capture all the meaning and all the pedagogical intention that was delivered into these books. So it's mean, okay, as I said, differentiating images and text, but also text between text and maybe some exercise between lesson materials. The other challenge was to defining classes. So classes means that we have to understand the way it has been constructed and how the pages have been constructed in order to define and to understand the semantics behind them. And this is another challenge that we'll see because behind the box model of each line of text, there's something, well, that we could try to resolve is it an exercise I'm looking at, or is it a lesson? And we have set up different analysis and methods. And the analysis, as you can see, could be very different from page to page. One thing that's very important is we have to train the machine to understand the reading order of the pages. And between very simple reading order to more complex reading order. And you have main parts and what we call the sides. It's always constructed this way. And the linear reading order is quite difficult to understand when you see pages like that. So you have to specify a few metrics to define how do you train the machine again to define the reading order which is acceptable. And another particularity is that as anything, the display and the layout of the scholar books evolves in time. So it's not because, well, if you take the same book, which is the same book here, 3 years ago and the next version now, you see the display is quite different. So you have to be able to be flexible enough in determining the reading order and all the elements within the page, even if the display and the layout evolves in time. So all this information, which is extended a tree, which shows a lot of complexity into a single page, for example. And all those elements, if you don't want to do that by hand, we need some machine learning to understand and deep learning to better help us for destructure the pages in order to restructure the pages into reflowable content. So you have some what we call regularities and irregularities. So this is one key feature that you could rely on when you look at the page, and you could see, okay, there's a blue background with a white color of the font, or a violet background, and so on. So you could detect some difference on what we call regularities. So regularities means this is often encountered, and the irregularities, oh, there's something new I've never seen before. You have, okay, you could rely on typography. In the complex layout, you have very, very different typography inside the book. So you could try to rely on that. So what we show there is typography and some wording, which is come over the pages, and so you could rely on these specific elements to what we call remarkable elements to understand what is written just under the elements. The more difficult part is to try to understand how is built the exercise, how the exercise is made, and how you differentiate the question, the answers. If there are many questions, how do you cut the exercise in 2, 3, 4, 5, 6 elements? And this is a very tricky part. So I'll let you see that the challenge is very important. That's all those elements which decide us to invest into some research into using artificial intelligence to try to construct better production plan to define reflowable content. And as I said, we start in 2018, and I'm very pleased to show you some outcomes that we deal on. First, we set up a lot of data sets, but because we've made more than 3,000 books already now, and we have worked on 3 million pages, we have a lot of data sets already available. But it's not sufficient. We have to mix all the different components of those data sets. So which means we need to use the PDF, use the XML that you could extract from the PDF, use the XHTML, which is produced from the conversion, and use the images of the pages also. So there's a very large data sets that you could deal with. And what we end up at the moment is that in our objectives, which is to create digital refillable content, we found that the best result is obtained by using the machine learning mechanism instead of deep learning mechanism. It's far too complex. The results are too complex to obtain, and good result to obtain with deep learning. We need to have more than 3 million images, and each image should be labeled in order for the machine to be trained for the deep learning. That's a challenge we couldn't afford. So we found good results into using the machine learning and statistical analysis. I will show you that as a remarkable element, we have a label processing, which is very good, a feature extraction, which is very good also, and a data visualization, which could make classes, which is relatively fair, using, again, the machine learning. So we couldn't achieve that with deep learning by itself. Of course, we could mix both, so that's the next future, but the basic and the first result that we obtained was the data visualization limited to a statistical organization. And once you have that, you build your pipeline. So you have, at the moment, the use of the artificial intelligence is very eased by the way you could find a lot of new open source project, which we could afford with. You have trained people in France and very trained data scientists which have been on our side to help us defining all these setup for the processes that we made up. I would launch the demo, and instead of the demo, we have made a very short video of what we've done on the machine in our office. So if the video could be launched. Yeah. So, which is very interesting. Say you start using, you need to get a random page selection, and we labels only 10 pages. With 10 pages on the book, which is fully labeled, of course, and labeling has been through all the extraction that we made, we could indicate to the process what we want to recognize. If you label 10 pages on the book, we are able to train the machine and to let the machine make the prediction on all the pages. So that means practically, if you spend 1 day, and 1 day is a large amount of time, you could define a prediction and you could calculate all the display VOC resources that we wanted. The VOC resources is a visual object classes, which is a specific format for the used by the artificial intelligence, and the result is there. So you are in our product here, a reader, which shows all the different. So you see, it's almost perfect. We have everything captured the way that we want it. You see different colors mean different specification that we train the machine with. And once you've done that, we export all the material that we've captured into widget. And the widget, very easy to make accessible. For example, here, the fixed layout EPUB, and now the widget. And the widget is the text there, so you could add up any kind of accessible functionality, and it works like a charm. Another way, this way, and this is built. So we built a 500 pages book in 3 days, like that. So it's quite amazing now. So if we're back to the. That was the end of the video. I would just back to the PowerPoint presentation, or just to say the roadmap that we are, where we are and where we're going to. And on the roadmap, we have, we are in the building the production process at the moment. So we are fairly satisfied with the research and the results, the VOC results that we have obtained. We have integrated that into the EasyCrunch platform, and now we are producing with it, and we're delivering our product by beginning of next year, so beginning of 2020. Thank you.
Hello, I'm Ted from the Dutch National Library. I wonder, you have now material which is all digital, like PDFs and XML going in. Do you also see possibilities to do it with digitized materials? Have you been looking into scans and making there the OCR, etc.? Do you think the techniques can be applicable for that as well?
Yes, but we have to make some data sets, specific data sets when you get from scan material. We need, as you see, the machine learning links some styling information. So if we could do some OCR, or if we could improve the data sets, we could do that. But after that, the process should work on any kind of materials, printed materials.